Hi everyone, I'm Sushmita. Now I'm going to explain about the retrieval augmented generation, which is a RAG. So I'm going to explain the RAG architecture. And normally, if we want to know anything, we'll ask ChatGPT or any LLM model, but it has some limitations. Those are actually LLM model will give the responses if the information is in the trained period. If the LLM train date is up to January, now we'll want to ask or we'll want to ask any question or anything that happened after January, it won't give to us. Why? Because it doesn't know it. So each LLM has a knowledge cutoff date, and if I ask anything about yesterday's news, it won't give. Why? Because it is not trained before. If I give any PDF with large information, the LLM will not give any responses to us. So why? Because it can't handle the huge data. And also, if I want to ask any organization's data, it doesn't know because it doesn't know the organization's data. Means they'll keep it secret, right? And we also have a limitation of data privacy. And if I want to ask anything that's not there in LLM, then the RAG will be used. So RAG is used for if we want to fetch anything from our data. Here we'll use the RAG. So this is the architecture of the RAG. So actually ARG is two parts. One is text generation workflow and another one is data ingestion workflow. So what data ingestion workflow and what text generation workflow? Now I'll explain you. So this is data ingestion workflow. What happened here is actually here we'll have a text. Means anything, a text from PDF or from document, whether it may be a video or it may be a scanned document or it may be text, anything. So here we'll have a text. What happened here is we'll take that raw document, the text from the PDF. Here what we will do is uh, we will do the chunking here. Chunks means dividing the passes into small pieces. So here what I'll do is I'll do the chunking here, and here what I am doing is by using the embedding model I am doing the embeddings. So what is this embeddings? Oh, embeddings means converting the text into the numerical representation. So to convert those chunks into embeddings, here I have used the embedding model. So it may be anything. Embedding model, it may be sentence transformer or it may be anything. So by using these embedding model, I'll convert these chunks into embeddings. So now what I'll do here is, so these embeddings will be stored in a vector store. This is a vector database. Suppose like it's like a normal database. We have many database servers like SQL, MySQL, SQLite. So like that, we'll have a vector database here. The vector database be like it may be Fias, it may be Qdrint, anything. So I'll store these embeddings into this vector store. And here, text generation workflow. Here, what happened here is user will ask a question from the PDF. So user will ask the question. So what happened here is that question will be chunked. Same the process repeated here. Uh, the user questions can be chunked and that chunks can be converted into the embeddings by using the embedding model. So these are the embeddings. Embeddings means numerical representations. So numerical representations, these will store in between the 0 to 1. See, 0.89, 0.02, 0.53, any value between the 0 to 1. So these are the embeddings, and same process. These embeddings will be stored in the vector store as well. So these PDF chunks will be stored in this vector store, and these user questions embeddings will be stored in the vector store. So what happened here is, I'll use the semantic search. It may be any search, semantic search, cosine similarity search. So by using this search, here what happened, what is the use of this search is, it will compare our embeddings with the text embeddings, text what we have taken from the PDF embeddings with text embeddings from the user input. So it will compare these two. So by using the semantic search, it will give us the most related embeddings to our question. So this is a question. So uh, the related embeddings to this one will be uh, retrieved from this vector store. So this is a retrieval. So what or RAG means? Retrieval augmented generation. So this process is called data ingestion. This process is called text generation flow. So uh, both embeddings are stored in this vector store, and by using the semantic search, we'll get the similar chunks to the to our questions by using this semantic search. So here what I get is context, means the answer we got from the vector store. Answer means same similar one to the embedding model. So here I'll get the context. So this process is called RAG, means retrieval. What I am retrieving means fetching. So what I am fetching here is the similarity search. By using similarity search, I am getting the similar embeddings to the user input. So here I got the output as a text. So this is the retrieval. So here what happened is, I am using this context and I am adding the prompt. So this prompt means like I'm telling to this LLM means how to behave. So this is your role. So this is the work you have to do. This is how you should give responses. So these are the instructions I'm giving to this. So context plus prompt. So these two, context plus prompt, will be given to the large LLM. Sorry, a large language model means LLM. So these two we are giving to the LLM. This process is known as augmentation. So this is the retrieval. This is the augmentation. So LLM will take this context plus prompt and it will give us the result. It will generate the result. So this is known as generator. So this is the architecture of the RAG. So at last what happened here is, it will chunking, it will do chunking. The chunks will be embedded, and that embeddings will be stored in the vector store. Same as user will ask a question, and that question will be chunked and embedded. So those embeddings will be stored in the vector store. So it will compare those by using the uh, top k value what will be given by the user. So if I give the top k value means similar words, so top matching words. If I give 4, it will check, it will give the top 4 matching answers as it will give to us. So here for chunking also we'll give the same one. will give the size to these chunkings. So based on the size, it will chunk. Chunk means smaller pieces. So here we'll also give the overlap. Overlap means if we have any similar answer after the chunking, so we may lose that data. So actually, for example, my name is Sushmita. So what happened here is in chunking, I'll get my name is, but what the real answer is, I'm in another chunk. So here I may lose the data. So if I use the overlap, I'll get the my name is Sushmita. So for that, I'm using here overlap. So this is the architecture of RAG. So thank you.